Welcome to AR Logics. This is Venkat, chemistry faculty. Today we are going to discuss about oxidation number rules. So this concept was very important in IPE pattern as well as the in competitive patterns. Why? Because with the help of the oxidation number, we can decide which is the oxidation reaction and which is the reduction reaction. So and which is the redox reaction. First of all, let me discuss about oxidation number rules. So there are 8 rules are there. So first rule number 1, when an atom is present its elementary state or molecular state, its oxidation number is 0. Its oxidation number is 0. So first rule is, if an atom present as elementary state, elementary form or elementary state or molecular state, its oxidation number is 0. Its oxidation number is 0. For suppose, if I am taking hydrogen, if it is present its elementary state, or any oxygen present as elementary state, or any sulfur it is present at elementary state, we should write that oxidation number as 0. Or else molecular state means, for suppose as H2, Cl2, P4, S8. So these are the molecular state. So here also the oxidation number of these are 0. So that is the rule number 1. And rule number 2, what is rule number 2? So means here for all alkali metals, the oxidation number is +1. For all alkali metals, the oxidation number will be zero. The oxidation number will be 0, not will be 0, it is a +1. For suppose example, alkali metals means lithium, sodium, potassium, rubidium, cesium and francium. So like elements, so these as only +1 oxidation number. Next, rule number 3. What is rule number 3? For alkaline earth metals, the oxidation number will be 2, +2. Oxidation number +2. Oxidation number +2. For example, beryllium, magnesium, calcium, strontium, barium, so etc. elements has only +2 oxidation state. Next, rule number 4. For hydrogen, the oxidation state of hydrogen, the oxidation state of hydrogen is always +1. But when it is combined with metals like alkali metals or alkaline earth metals, it has -1. But when it combined with alkali and alkaline earth metals, it is -1. It is -1. For suppose example, sodium hydride. So in sodium hydride case, here the oxidation number of hydrogen is -1. At the same time, here in the case of calcium hydride, the oxidation number of hydrogen also here -1. In other cases, it's +1, but it is combined with alkali metals or alkaline earth metals. It is -1. It is rule number 4. Next, let me see. Rule number 5. Rule number 5, which can explain about the oxidation number of oxygen. The oxidation state of the oxidation state or oxidation number. The oxidation number of oxygen, number of oxygen is always -2, is always -2, but in some cases, in some cases it changes. What is that? For suppose in peroxides, it is -1. In superoxides, it is -1/2. It is -1/2. For example, for peroxide H2O2 hydrogen peroxide. In hydrogen peroxide, the oxidation state of oxygen is -1. For example, for the superoxide, example is KO2, potassium superoxide. In this potassium superoxide, the oxidation number of oxygen is minus half. So this is rule number 5. Next, rule number 6. Rule number 6 means always the oxidation number of fluorine is -1. Oxidation number of fluorine atom. Fluorine should be always -1. It is not changes in any compounds. It is rule number 6. It is the rule number 6. Next, let me see rule number 7. Rule number 7. So what is that rule number 7? So for neutral compound, the sum of the oxidation number is equal to 0. The sum of the oxidation numbers of the atoms in the compound is equal to 0. The sum of oxidation numbers, of atoms in a neutral compound, is equal to 0. For suppose example, if I take one example, sulfur dioxide is a neutral compound. So in this case, here sulfur is one atom. So means here sulfur, for suppose oxygen has -2. So can I write here this is x plus 4 into -2 is equal to 0. Right now x minus 4 is equal to 0. X is equal to plus 4. Right now sulfur is +4. Two oxygens are -2. So means -2 into 2 -4. So means that is equal to what? 0 here. So that is the rule number 7. Rule number 8. Next, the sum of the oxidation number of atom in a ion is equal to charge present on that compound. For suppose the sum of the oxidation numbers in a ion is equal to its charge, For suppose example, if I am taking MnO4 minus permanganate anion, it is a ion. In this case, for suppose x plus we should write as 4 into -2 is equal to -1, x minus is equal to -1, x is equal to +7. So that is equal to what? -1. Why? Because charge is present on that. So these are the 7 oxidation number rules. So by using the 8 oxidation number rules, we can calculate some examples. For suppose example, HSO4 minus, in that we can find out oxidation number of sulfur. So you can take that one as X. Always hydrogen is plus 1. Why? Because these are the not metals. 1 plus X plus 4 into, always oxidation state of oxygen is minus 2. Minus 2 is equal to minus 1. Why? Because it is an ion. Right now 1 plus X minus 8 is equal to minus 1. Right now 1 plus X is equal to 7. X is equal to 6. X is equal to 6. So this is the example. So it is about the oxidation number rules. Thank you.